Welcome to qnawire.
So this question gives us the energy gap for silicon at a room temperature, so around 300 Kelvin. Gives us the band gap of 1.14 electron volts, and it asks us to find the lowest frequency photon that can promote an electron from the valence band to the conduction band. So as you can see, we'll draw out the two bands here. So we have two bands. So this will be the bottom of the conduction band, and this will be the top of the valence band. And what can happen is an electron from the conduction band will recombine with a hole in the valence band, like this downward transition shows here, and we can get an emission of a photon as a result. And the energy of that emitted photon will be equal to the band gap, Eg. So as a result, our band gap energy will be equal to the energy of that photon, so Eg will be equal to Planck's constant h multiplied by the speed of light in a vacuum c over the wavelength of the photon. So as a result, our band gap energy Eg will be equal to the energy of that photon. So we have Planck's constant h and the frequency of the photon f, and we want to solve for f. So of course, rearranging gives us the frequency f is equal to band gap energy Eg over Planck's constant h. And we want this in SI units, so this will be equal to our energy of the band gap in electron volts multiplied by the elementary charge. So 1.14 is our energy multiplied by 1.6 times 10 to the minus 19 coulombs over Planck's constant, which is 6.63 times 10 to the minus 34 in base units. And this will come out as 275 terahertz. The second part then asks us to work out the wavelength of this emitted photon. So we can rewrite this equation so that our band gap energy or photon energy hf is also equal to Planck's constant h multiplied by c, the speed of light, over the wavelength lambda. And all we have to do now is solve for lambda, so we can see that lambda would be equal to c over f, as the h's will cancel, and this is equal to 3 times 10 to the 8 over 275 times 10 to the 12. And this will come out as 1.09 micrometers.